Okay, so let's look at something now we're introducing with absolute value. Okay, the absolute value of x is greater than or equal to 5. What does absolute value mean? Come on. Absolute value is always a positive number. So we know that absolute value is always positive. I mean, you should have learned the absolute value of -5 is 5. Absolute value of -4 is 4. Okay. Another way to think about absolute value, so absolute, think of it as the distance from 0. How far is the number 5 from 0? 5. How far is -5 from 0? 5. Okay, so you had no trouble, even though it was -5, the distance is positive. The distance is not a -5 distance away. So think of it as distance. So what this is saying right here, absolute value of x greater than or equal to 5. It said, what are all the numbers that are a distance of 5 or more away from 0? Okay, so if I go to the right, this is 5 units from 0, and then these are all more than 5 away from 0, right? Over here. So this is 5 units away from 0. These are more than 5 units away from 0. How far is this from 0? 5. And these are more than 5, right? Yeah. So what happens when I look at that absolute value greater than 5, I get two areas. So it's saying, what are all the numbers that are at least 5 units or more away from 0? So in this case, when I look at x greater than or equal to 5, I only got one interval. Here, how many intervals do you see there? 2 intervals, okay? So what are those intervals? So those intervals are what? -infinity to what? -5, okay? Parentheses, what goes around the -5? Bracket. And then I've got another interval that goes from where? 5 to infinity. So this is the answer that represents this solution, okay? So just by putting absolute value of x greater than or equal to 5, I get 2 intervals that are there, okay? Now, I'm not going to write this in inequality because I'm really only interested in interval notation, okay? Now, let's look at the next question. Right here, x, absolute value of x less than or equal to 5. Think of this. This means the distance from the origin is 5 or less, okay? So, where would I go? Here's the origin. Where do I go to get things that are 5 or less? The distance from the origin is 5 units or less. So what's the farthest I can go? 5. So I can go over to here, okay? Are all of these things less than 5 away? So I would be shading which direction? These things are all less than 5 away. Now let's go to the left. Where can I go and be 5 units away? Okay. Where are all the numbers that are less than 5 away? This way, okay? So you can see this is what it looks like for the absolute value of x less than or equal to 5, okay? And then what is this in interval? We'll write it here. In interval notation, what is this? Yeah, this is all the numbers from -5 to 5, and it includes both of those numbers. Now, how would that differ if I had the problem that you see here? All the numbers at the absolute value of x is less than 5. So draw a number line. These are numbers whose distance is strictly less than 5 units away. So if this is 0, 5, and -5, what kind of circle goes on 5? Open. Okay. And then the distance is less than 5. That would be an open circle here, and I shade where? Everything in between. Okay. These are all the numbers that are strictly less than 5 from the origin. So in interval notation, this is the interval from -5 to 5 with what kind of enclosures? Parentheses, okay? If I were writing this as inequality, it would be x is what? Less than 5, greater than -5. So that's what this means, is all the numbers that are less than 5, but at the same time greater than -5. Okay? So absolute value introduces a little bit of complexity to our problems. So what we're going to do, we're going to cut through that complexity, and we're going to come up with a rule for how we deal with that. So anytime I have a problem that looks like, something like this, absolute value, and I got a problem that looks like this, what you want to do, our goal is to break this into 2 separate problems, okay? First problem, write down everything just like it is without the absolute value signs. So I'm going to write ax plus b less than c. And then the second problem, I'm going to do 2 things. I'm going to change whatever this sign is. If it's a less than, it becomes a what? Greater than. And then I'm going to change the value of this. If this is a c, I'm going to flip it to be a -c. Now, this will make more sense when we just start working. Now I go work these 2 problems, okay? So rather than be confused, you see what happens here was when I had absolute value greater than a number, I got 2 areas as my answer. When I had absolute value less than a number, I got 1 interval. So there are different ways of handling that. What we're going to do is just break everything into 2 problems, and you don't need to worry about that. It's all going to work out. So I see absolute value. I need the absolute value to be all by itself. Is the absolute value all by itself on one side of the equation? Yes. I mean, all I have on this side of the equation is absolute value. Okay? Like, it would not be if I had this. If I had this, this would be the absolute value is not all by itself. What would I do to get it by itself? I could add 6 to both sides, and then I would get this. Okay? So that's what I mean. On one side of the equation, all I see is absolute value. Okay? So I'm ready to break it into 2 problems. First problem, write down everything you see without the absolute value. Okay? Second problem, I make 2 changes. 2x plus 7. Instead of that being less than or equal to, I change it to what? Greater than or equal to. Instead of that being a positive 6, I change it to -6. Okay? So every one of these absolute value problems, we're going to break into 2 problems, work the 2 problems. Now, this would be a problem like you had for last night's homework. Work the 2 problems and come up with an answer. So what's the first step here? Subtract 7 from both sides. So I get 2x is less than or equal to -1. Then what? Divide by 2. And I get x is less than or equal to -1/2. Over here, first step is to do what? Subtract 7. And I get 2x greater than or equal to -13. Now I do what? Okay, Michaela was sleepily saying that you divide by 2. So x is greater than or equal to -13/2. Okay. Now, which of those numbers is smaller, -13/2 or -1/2? -13/2. So I'll go to my number line. -13/2, -1/2. What kind of circles go on those numbers? Closed circles. Okay. I'm shading that I'm greater than this number and less than this number. Where am I shading? In between them. Okay. So that's my region. How many intervals did I just draw? 1 interval. It's an interval from where to where? Yeah, you just read this numbers off of the chart. What kind of enclosures go around that? Bracket. and you're done. That's it. Okay. So what's different than what we did yesterday? When you see absolute value, you break it into two problems. Now, when we saw like the compound, we broke it into two problems just by copying what we saw. But when it's absolute value, you break it into two problems, but you have to, the first problem, you write down everything as it is without the absolute value. The second problem has two major changes. Whatever the inequality sign was, it flips. And whatever the number that's off by itself is, it changes sign. If this had been a -6, then that would be a +6. You would change it. Okay. So we'll get into some other special cases there. But let's do another example here. Is the absolute value all by itself? Yes. Okay, so I can break this into two problems. So copy down everything, -3x plus 4 less than 11. Okay. Now, to make the next problem, what do I do? -3x plus 4 is what? What changes? There are two changes. This becomes what? Greater than what? -11. Okay. So with absolute value, first problem, copy down everything you see without the absolute value. Second problem, you copy down the problem, but you make two changes. Whatever this sign is changes. Whatever the positive negative sign of it, whatever this inequality was, you flip it. Whatever the positive negative sign of this was, you change that. Now we solve both problems. What do I want to do? Yeah, subtract 4 from both sides. And I get -3x is less than what? 7. Now what? Divide by -3. There are bells going off in your head. Why? Yeah. The minute I divide by a negative number, what has to happen? That has to change. So this is x what? Greater than -7/3. I want to see that. Okay. So that's good. Now let's go get a solution here. Subtract 4 from both sides. And I get -3x is greater than -15. Now I do what? Divide by -3. You're doing the same steps when you solve this. The bells in your head go off because that has to change. This is x less than 5. So which of those numbers is the smallest? Yeah, -7/3. So this is -7/3 right here. This is 5 over here. You understand, I'm not being exact here. I'm just picking relative spaces. What kind of circles? Open circles, okay? And where do I shade? In between them, okay? How many intervals is that? One interval. It's the interval from where to where? Yeah, -7/3 to 5 with what kind of enclosures? Parentheses, okay? Okay, so this is a repeatable process, you know. We're doing the same thing repetitively here. You guys work on this one, okay? So 2x plus 7 minus 1 less than 4. what I'm going to have to do to get the absolute value here by itself. What's the first thing I'll do? Subtract 1 from both sides. So you're going to have so the first step is subtract 1 from both sides. Then what will you need to do? Divide by 2. So everything has to get divided by 2. Then you get x plus 4 greater than or equal to 4. Now you proceed to start with the process to break it into 2 problems. Okay, so this one we worked here. Like I said, there was a little bit of work to get the absolute value by itself. You had to subtract 1 from both sides, then divide by 2. Once I got it to here, now I'm good to break that into 2 separate problems. X plus 4 greater than or equal to 4. X plus 4 less than or equal to negative 4. You get 2 inequalities, you get 2 solutions. You take those solutions, put them on a number line, and then you can read, this is going to have 2 intervals, okay? Anytime I have 2 intervals, I'm going to join them together. So this is negative infinity to negative 8 with a bracket. That is 0 to infinity, okay? Now, one thing you have to pay very close caution to are problems that look like this. These are a couple of special cases, okay? So x plus 5 greater than negative 5. So here's what you have to do. When you've got the absolute value isolated, okay, and you got a negative number over here, you have to pay close attention. So the absolute value of x plus 7, what kind of number is the absolute value of x plus 7? It's a positive number, okay? So on the left side, I have a positive number, okay? I could have written that right here. So positive number. On the right side, what kind of number do I have? I have a negative number. What's the inequality that's in between them? Greater than, okay. Are there positive numbers that are greater than negative numbers? Which ones? All of them. All the positive numbers in the world are greater than all the negative numbers in the world. So this is asking for all the positive numbers that are greater than negative 5. What are they? All real numbers, okay? So this solution is all real numbers, okay? The key that this one was a little bit different was when you see this negative over here, okay? Now this would be a little bit different if the problem had been x plus 7 is greater than 5. Okay, this one I would break into 2 problems. I would write x plus 7 greater than 5, x plus 7 less than negative 5. I would subtract 7 from both sides, just like we've been doing, x greater than negative 2, and then x less than negative 12. So numbers that are greater than negative 2, less than negative 12, I would draw this on a number line. And this is what, negative infinity to negative 12, negative 2 to infinity, okay? That's the way I would work this problem if this had been a positive over here. Anytime you see a negative number, You can try this process. You're going to get nonsense for your answer. If I had written down x plus 7 greater than -5 and then less than +5 and tried to work through and get an answer, it's going to be nonsense. So you've got to bring a little bit of intelligence. When you see a negative number here, just look at it and say, okay, this is positive, that's negative. What positive numbers are greater than the negative numbers? Every one of them. Do you see where we got that? Now, the other way that works is something like this. Look at the next one. On the left side, that's what kind of number? Left. Positive is absolute value. On the right side, what kind of number is that? Negative, okay. Now, they are asking me for all of the positive numbers that are less than or equal to -1. What are all the positive numbers that are less than or equal to -1? There are none of them. So this has no solution. If you were not to catch that and you just start working it, like I said, you're going to get an answer that doesn't make sense. Okay. So anytime you see absolute value isolated and you got a negative number over there, your answer is going to be all numbers or no numbers. Okay. So the way you interrogate that is just say, these numbers are positive, that number is negative. There are no positive numbers that are less than the negative numbers. Okay. The other question was the positive numbers greater than negative numbers, all of them. So it's going to be all or nothing for that. Okay, so be careful if that one crops up. So just to review where we are, and you can turn loose on the homework. We've done simple inequalities so far. Now, what we do here is when I see an absolute value, I need to separate that into two separate inequalities. So an absolute value and a positive number, you break that into two problems. The first problem you write down as is, and then what happens with the second problem? You do two things. Yeah, flip the inequality and change the positive negative sign, and then solve it, and then it's just go to number line, then go to interval notation. Okay? But you have to pay close attention to when you have absolute value, you have the negative number over there. You're either going to get all numbers as a solution, or there are no numbers that are a solution. Okay?